You have heard of the periodic table. You know, that large and complicated table with all the elements. Oh, this one looks pretty well designed. Now, really complicated on initial glance, this table's quite daunting, and I'm sure you've had trouble trying to memorize it. Now, hopefully you've seen the table before. You'll be well familiar of things like atomic number, atomic mass, the element name, the symbol, the abbreviation, likely the different families or subgroups, aspects like group number and period, and well, you probably know at least like 50 of them, right? Wait, we're supposed to know these? Wait, why would you want to know them? There's so many, 118 elements. That's way too much. There's no way anyone can like memorize it, surely. Okay, what if I said it was actually possible for you to memorize all of them, and in fact, you could add in other details. You can memorize the elements, that's easy. You can even add in things like atomic number, maybe the group number. If you were really keen, maybe some chemical properties. You could even do other features. But how? How could we do this? Is that even possible? Wait, what if I said it was possible? Ah, I know what you're thinking. Periodic song. I like the way you think. That's good. Yes, periodic song is absolutely incredible. But there is a flaw with the periodic song. Not to say it's not a great device. Absolutely go for it. It's great, great fun. But there is a problem. I'll give you a demo. If I asked for a specific element, you're going to have to sing the song the whole way through until you get to that exact element that you need. So we'll do just a brief demo. Right? If I said hydrogen, you're going to go, okay, that's easy. It's number 1. But if we fly through and let's say I'm a little bit mean and I'm like, oh, what's element number 19? And you're like, hydrogen, there's helium. I mean, that's going to take a while. Not to mention, if you make a mistake or if you lose track halfway through, you're going to have to sing the song all the way through. And obviously you'll track it with the table here, very handy resource. But that's actually going to take, you know, a really long time. So what if I said there was something better, like a shortcut, like a hidden learning secret? I don't think you can find it anywhere else. This might be the only place. You're in the right place. Let's go for it right now. I'm going to show you how to use this technique. And by the end of it, do I guarantee that you're going to learn the first 20 elements? I feel like that's a bold claim. You're going to have to keep me to it to see if that's even possible. But I'm confident. I think you can learn the first 20 elements in 20 minutes or less. Oh, that sounds like a challenge. Let's go for it. Launching right in. But before we do, don't start the timer yet. Do we start the timer yet? No, not yet. In fact, no, let's start the timer right now. Why not? First question, what is it? What is this table about anyway? Well, take note, atomic number, electron configuration, and chemical properties. The original inventor was actually a Russian chemist by the name of Dmitry Mendeleev. Now, Dmitry did a good job here of actually organizing these elements, and the end result is absolutely a flawless periodic table after many decades of refinement. Now, why would you want to learn it? Well, you could argue that it matters because elements are the building blocks of matter. Therefore, it matters. It's logical. It's okay, you got the pun. Now, what if I told you it was possible to take all of the elements, or maybe not all of them, but at least the first 20 to start with, right? You don't just jump in the deep end, you've got to warm up. So we're going to go for the first 20. We're going to add it onto a specific device. You'll see it in a second. And we're also going to add other details because I feel like that's too easy. Just memorizing the first 20 elements, that's a breeze. You can do that without even breaking a sweat. So let's go for something more challenging. That could be as easy as telling time. Okay, enough teasing. Let's launch into it. Here it is. From periodic table to the periodic clock. That's right, we're going to take 20 elements, we're going to translate them onto a standard 24-hour clock, and by the end of it, we should end up with a memory device that is going to be really effective. Areteerga, the Academic Institute of Excellence, presents the periodic clock. Okay, let's go for it. Now, keep in mind, as we map these out, we're going to set up a cue on the clock that's going to help us to recall the information that we need. So that being each of the properties of those different elements. So if you haven't already, grab a pen and paper. Let's launch right into it. We'll make some good notes and see if we can master this. That should be easy. Element number 1, wasting no time. It's hydrogen. Key properties of hydrogen. The symbol is H. And take a look at the atomic number and the atomic mass. We're sitting on a mass of 1, which, in case you're not familiar, means it's going to have 1 proton And with that 1 proton, there'll be 1 electron, unless it's the ion, but that's a whole different video. Let's keep going. Take note, it's in group number 1. Very powerful knowledge. Actually corresponds to the number of electrons in the outer valence, but that's a whole nother video as well, remind me. And take note, hydrogen makes up around 70% of our sun, maybe up to 75. The numbers vary because I don't think we have an accurate measure. And the other component is going to be element number 2. Very convenient. So hopefully you've jotted down some notes on that. Next element. Then there's helium. Helium's abbreviation, He. It's going to be within our particular table, number 2, which is way off on the far right-hand side. And take note of our mass and atomic number here. We got 2 for the atomic number and a mass of 4. Don't worry too much about the decimal for now. It's complicated, but we'll explain that in a future video too if we need to. Next one, group number. It is a noble gas. Very, very important detail. Okay, now helium is a colorless gas. And in terms of use, you must have seen this before in helium balloons or floating balloons. Man, those are a lot of fun. Okay, going well. Next one. Number 3 can only be lithium. Abbreviation or symbol Li. Element number 3 or atomic number. Take note of the mass there. We're approaching 7, very close to 7, 6.94. And in terms of our group number, we are in group 1. Now, it's probably important to point out at this point that those subfamilies, if you were interested, could also be added to this device. And this particular one is an alkali metal, giving it very specific properties, and it's common to everything in that first group, which is kind of interesting as well. Except obviously for hydrogen, which we did earlier. Okay, appearance. We have a soft silver white metal, and quite a useful metal as well. We see this a lot around us in our devices. So take note of the common uses. Most of those devices, modern day at least, use lithium as their power source and battery. So pretty cool. Okay, number 4, we're up to beryllium. Take note of the spelling of beryllium. It's not double R's, only 1 R. It would have been nice if it was berry. That would have been easy to remember, but beryllium, that's a funny word, beryllium. Take note of the abbreviation. We got Be, very important. Atomic number 4, mass. We're pushing 9. So that's getting a little bit heavier here. Take note of the increase in neutrons relative to the number of protons. We're in group 2, so sitting right next to our previous contender, lithium. And these are part of the alkaline earth metals. Now in terms of appearance, we're talking soft silver white metal, very similar to the previous one and of particular interest. Where can we find it? It's actually found a lot in gears and cogs and technical things like machines. Convenient. Okay, number 5, boron. What do we know about boron? Well, starts with the symbol B. We have a mass of 10.8. Atomic number 5, so nice and round numbers on that one. Group number is 13. So we're taking a bit of a transition here off to the far, or towards the right of our periodic table. And in terms of family, this is part of the metalloid family. Next one there, appearance. Boron is a little bit brittle and is a lustrous metal. Now, of particular interest, where can we find it? Well, it's actually found in borax. You may have seen this either in the laundry when removing tough stains, or maybe in something like slime in a science experiment, which is kind of cool as well. Okay, so far so good. Now, what do we do now? Well, we must do some revision, otherwise we're not going to remember any of it. So we'll fly through 1, hydrogen, helium, lithium, beryllium, boron. You can sing the song, that one's easy. Now, key thing to do next is to add in a key word that helps us to identify each abbreviation. Okay, this gets interesting, but we'll go for the obvious. Sun, balloon, battery, gears, and soap. Well, that's kind of convenient. Should we add more? Let's add another layer. We're really pushing this memory thing. Now for the next one, choose an image that can represent either the word or the element. Maybe you want to mix it up a little bit, your choice. But I'm going to go with a nice diagram of the sun. Excuse my artistic hand, it's not as good as it can be, but that's not too shabby. We have the balloons. We have a lithium battery by the looks of it. A couple of gears moving together and a little bit of soap. Oh, that's pretty handy. Very handy with all these viruses going around these days. Anyway, that takes us on to element number 6. This one's pretty famous. You must have heard of it before. Carbon. Yes, take note. We are atomic number 6 as well. Convenient. Mass is doubled, so pushing 12.01 on this one. Group number 14, this one's well worth memorizing, very important. And take note, it's a non-metal, similar to hydrogen. In terms of appearance, well, you've seen this one before for sure. Think of something like soot after maybe a fireplace is burnt up. Soft, black, and it's a non-metal. Very important in terms of properties, can be quite soft, but obviously you know about some of the common uses. The classic ones would be things like pencil lead, not this pencil, another pencil. You also have things like graphene, which is 200 times stronger than steel. That's pretty cool. And another classic example would be the diamond, which is actually the hardest natural substance. And it's made of carbon. How cool is that? Okay, it takes us on to the next one, which is going to be nitrogen. What do we want to know about nitrogen? Abbreviations N. Atomic number 7. Mass of 14.0067. We're in group 15, and yes, it's also a non-metal. Now, in terms of appearance, it is a colorless gas. And common uses, there are many, but one interesting application would be ammonia, which is actually agricultural fertilizer. Pretty versatile, these chemicals. Next one's oxygen. Symbol's going to be O. We have atomic number 8. Mass of 15.9994. That's a pretty accurate number. Group number, we're pushing 16, also a non-metal. And lots of different uses here, but take note, it is a colorless gas. I mean, you're not surprised by that one. And take a deep breath before we say that. And take note, commonly found in, you could choose anything, but I'm just going to go with the obvious, water. If you haven't already, take a quick drink of water. Very important, stay hydrated. But there are other applications like O2 made during photosynthesis. I'm sure you know that formula quite well. What was it again? 6CO2 plus 6H2O. Add a little bit of light, producing C6H12O6 plus 6O2. Well done, testing your memory there, but that's a whole different video. Next element, we're on to fluorine. Symbol F. Atomic number 9. Mass pushing 18.998. In terms of group, we're up to group 17, taking us into the halogens. Very unique family, lots of cool properties. Now, appearance is a faint yellow, and it's actually a little bit irritating, so we don't really want to be running into this one too often. And there are some neighboring halogens that are a little bit toxic as well, so we'll come back to those. But of particular interest, we actually add fluorine to toothpaste. It's meant to help with tooth decay resistance, but it also received a lot of bad rep at some point due to being in CFCs. That's chlorofluorocarbons. Take note of that combination, chlorine, fluorine, carbon. And they depleted the ozone layer, so O3. And the end result of the depletion was an increase in skin cancer because more of the sun's harmful radiation came through. Oh, that wasn't a good idea. Okay, next one, neon. Symbol Ne. Atomic number 10. Mass 20.1797. Take note of the group number. We're up to group 18, putting us into the noble gases. And in terms of our appearance for this particular one, colorless, and it is inert, non-reactive. Now take note of our key point of interest. It's commonly found in high voltage red-orange neon lights. So next time I see a neon light, definitely scope it out. It could just have been this. Okay, quick revision while we're here. 6 was carbon, 7 nitrogen, 8 was oxygen, 9 fluorine, 10 neon. But you know it doesn't stop there. We could totally add a little bit more detail. Now take note, we might drop off on the bottom here. Hopefully not. Let's add in another keyword. Well, for carbon, I'm going to go with diamond, but there's so many to choose from. For nitrogen, we'll go with fertilizer. Oxygen, I guess we could do water. For fluorine, I like CFC, but you could do toothpaste, up to you. And for neon, let's go with light. Pretty easy. Okay, and now let's draw an image that helps us to identify it. Well, I'm going to go with the diamond for carbon, maybe fertilizer for nitrogen, a tap with a little bit of water for oxygen, washing those hands, and fluorine, let's go with toothpaste, keep it mixed up and different. The CFCs, they're very complicated molecules. Okay, and the next one there is going to be the classic light bulb, and that one looks like an energy saver, so that's always good for the Powerball. Okay, on to 11. Takes us into sodium, which is Na for the symbol. We're up to atomic number 11. The mass is 22.9897. Group number is all the way back, so jumping all the way to the left side. Group 1, it's an alkali metal. In terms of appearance, it's a soft silver white metal. Now, of particular interest, it's actually found in table salt. You must have heard of this before. Sodium chloride, the most common food seasoning. So I'm sure you've seen Salt Bay and other related videos as well. Very famous, the old salt. Sodium, very easy to remember. Next one's magnesium. Key thing on magnesium, abbreviation or symbol is Mg. We're up to number 12 in the table in terms of our atomic number. We're pushing, rather atomic mass, we're pushing 24.305. Group number, we're in group 2, taking us the alkaline earth metals. Appearance, a light silver white metal. And of particular interest, magnesium is commonly found in fireworks. That's right, next time you see those white sparkles in fireworks, you know exactly what they are. And that also means magnesium is pretty reactive. It combusts really quickly in air or oxygen, very important. Okay, number 13, also a very common metal. Aluminium, or maybe you call it aluminum, potato, potato, tomato, tomato, you know the drill. Abbreviation or symbol, Al. In terms of atomic number, this is number 13. Mass, 26.9815. Group number, it's group 13. It's a post-transition metal. Appearance, well, it's non-lustrous, and take note, it is also a silver white metal. You must have seen this around window frames, a very common example. But there are other practical applications, particularly in the automotive industry, where they make engine blocks from aluminium. And it's very common in aviation because it's a relatively light, but also strong, corrosion-resistant material, unlike iron, which is element number 26, but that's beyond the scope of today. Remind me for the next one. Okay, next one there, silicon. Take note, abbreviation, Si. Element number 14. The atomic number, 28.085. Group number 14, it is a metalloid. Appearance, it's a hard, dark grey, lustrous or shiny metal. Now, where do we find it? Well, you're probably using it right now to view this particular video. It's used in electronics, particularly in the CPU or the brain chip, the central processing unit of your device, computer, cell phone, tablet, whatever you're using, or maybe you're using augmented reality glasses if you're fancy like that. Okay, number 15, phosphorus. Take note of the letter. We're up to P for this one. Okay, next one there, phosphorus. Take note of the letter. Symbol is P. In this particular one, it's atomic number 15. The mass is 30.9738. It's group number 15. Also a non-metal, very similar to some of the others that we've had. In terms of appearance, it's a soft, colorless, but actually waxy solid. Of particular interest, it actually glows green in the dark. If you've ever had one of those watches with the natural phosphorus lining the characters within the watch, you'll know what I mean. But there are other sources like red phosphorus, which is actually found on the tip of matches. So if you've ever struck a match at a birthday party, you know exactly what that was. It's phosphorus. Okay, you know what's next. We need to do quick revision, flying through. 11 was sodium, 12 magnesium, 13 aluminium, 14 silicon, 15 phosphorus. Now let's add in that keyword. We had salt, fireworks, aircraft, chip, not potato chip, the other one, and phosphorus. Let's go with a match. Okay, not bad. Let's add in our diagram for each one. So I'm going to go with the salt shaker for sodium. Maybe you want to draw some fireworks for magnesium. I'm going to go for an aircraft drawing. That's a very accurate drawing. It's definitely taking off there. And for the chip, I'm going to go with the CPU chip. That does look like a central processing unit. And for our lucky last, phosphorus, I'm going to go for match. And that looks like it's been lit. Okay, next one, 16. We're making good progress. Sulfur. Key things to note on sulfur. Abbreviation S or symbol S. Atomic number 16, atomic mass 32.065. Group number 16, it is a non-metal. In terms of appearance, it's a pale yellow solid. and it's a little bit brittle. Take note of that as well. You must have seen it around because it's actually naturally released in volcanic regions, and you must have heard of it as sulfuric acid or H2SO4 if you've done a little bit of chemistry at school. And take note, it's got a low pH, making it really acidic and thus highly corrosive. Watch out for sulfuric acid. Not to be messed around with. Next one, chlorine. Take note, number 17 in our table. Abbreviation or symbol is Cl. We're up to atomic number 17. The atomic mass is 35.453. Group number 17. It is a halogen. Appearance, what's a green-yellow reactive gas. Very reactive, in fact. And of particular interest, it's commonly used as a disinfectant to kill bacteria. That's going to be something like bleach. And in terms of drinking water, take note, we actually have it in drinking water and in swimming pools for this very reason. Great for keeping those pools clean. Okay, next one, argon. We're almost there, so close. 18, Ar. There it is. Symbol Ar, atomic number 18. The mass is 39.948. This particular one is group 18, noble gas. Appearance, well, it's a colorless inert gas. Of particular interest, it's actually commonly used as a shielding gas in the process of welding. And this is where we fuse two pieces of metal together to create an incredibly strong bond because the metal has literally melted and rejoined. Pretty powerful stuff. Okay, next one, number 19, potassium. Symbol is K. Atomic number 19. Atomic mass 39.0983. The group number is 1. It's part of the alkali metal family. Yet again, appearance, it's a soft silver white, lustrous metal. Of particular interest, it's an important dietary component, and a common source would be bananas. You probably knew this already. And take note, it's actually needed for normal cell function because it maintains the intracellular fluid gradients. Pretty cool stuff. Okay, last one, number 20. This is exciting. We're almost there. Does that mean you know all the elements when we're done here? Maybe we'll test it. Okay, symbol calcium, Ca. In terms of our atomic number, we're up to 20. The mass is now 40.078. We're group number 2, which is the alkaline earth metals. It's a soft, silver white, lustrous metal. And of particular interest, it's also an important dietary component. Take note, milk, that class of milk, very important. And it's also needed for normal cell function. In fact, our muscles critically require calcium for normal cell signaling. Okay, this is good. You know the drill. Let's do a quick revision. 16 is sulfur, 17 is chlorine, 18 is argon, 19 is potassium, 20 is calcium. Add in our keyword as before. Let's do acid, pool, weld, banana, and milk. Key diagram, you saw that coming. Acid, let's do a little pool of acid. That does look pretty corrosive, very familiar. Next one, the pool, the classic pool. And that does look like a person swimming, not swimming from sharks, hopefully. The next one does look like someone welding, and who knows what they're welding. Next one there, the banana. Well, a couple of bananas, never hurt. Very important dietary source of potassium. And the last one there, milk. Now, dare I say, do we now know all the elements? I'd love to say yes, but you and I both know it's not that simple. Now we need to do a bit more. We need to refine our technique. Here it is, the magic. The key to this particular device is to memorize, at the very least when you start, position, shall we say north, east, south, west, or 20, 5, 10, and 15. By doing so, you have a point of reference that allows you to more effectively recall the other positions compared to something like the periodic song, which is awesome, absolutely awesome, but this is better. Okay, let's keep going. Test your memory in the meantime though. Definitely see if you can recall this one, but we'll jump on to the next section here and we'll see how we fare on the next group of elements. Okay, let's do a quick little bit of revision. Take note, as you expand on this, you could absolutely add more information, because keep in mind, the way memory works, if you can recall the element abbreviation, and you can now remember the atomic number, take note of that, all you have to do is hinge a couple of extra details to this. By linking other ideas, you expand your ability to remember more information about each of the elements. But we have to test it to see if it actually works, so hopefully it works for you as well. But take note, we had all our key words. We could absolutely do a practice run through here. And we had our key diagrams. Are you ready? Let's see how you feel. I'm going to test your memory quickly. Go! Hydrogen. Sun. And we had a diagram of sun. Helium. Oh, that one's blocked off. We had balloons. And we had a diagram of balloons. Lithium. Oh, that was easy. That was the battery. Little diagram. Beryllium. Oh, we had the gears and the cogs. I remember that one. Boron. Oh, yeah, that one was the soap dispenser. Very important. Keep those hands clean, especially during all these COVID times. Oh, yes, this one's easy. Carbon, and I listed diamond, but you may have listed something else. Next one's nitrogen. So many things to list, but I'm going to go with fertilizer. Oxygen, well, that was easy. You could definitely list oxygen. You could list ozone, actually. That's a good example as well. O3, and you could even list water, so that's easy. Oh, next one, fluorine, could only be CFCs, but I mean, you could do toothpaste if we want, but not the same thing. Very important. Next one there was neon. Now, neon is going to be a light bulb. Next one, 11, sodium, could only be the salt shaker. 12, magnesium. That was fireworks. Quite a bright spark on those magnesium strips as well. Next one, 13, aluminium, aircraft. Very easy. It looked like it was taking off as well. Then we had number 14, which is silicon, that computer chip. Yes, it was a good drawing, not the other, but potato chip. That's a whole different species. It's actually made of carbon, isn't it? There it is. 15, could only be the match, phosphorus. Okay, we're going well. 16, well, that was sulfur. And we had that horrible pool of acid, looked really corrosive. Number 17 was chlorine. Chlorine is found in pools and drinking water, very small amounts, but it helps to keep things sterile, kills off the bad bacteria. 18, argon. Argon is used as an inert gas, helping us to fuse metals during welding. We had that little guy with the blowtorch there trying to weld metal. And number 19 is potassium. Potassium is found in bananas, and we had a banana diagram there. 20, last one, calcium. It was milk. We had a milk bottle. Well, this is almost too easy. Wait, does that mean we now know them? Maybe. Maybe. We'll test it. But for now, to take note, to effectively encode all of these into your memory, there's at least 3 more things you got to do. The first one is practice recall. You already know this. Practice makes perfect. If you're not going to practice this, you will forget it. Very important. The next one is revision. And very similar, take note, for recall, you need to block off some of these sections and test your ability to remember that bit of information. And don't just do it in sequence, do it randomly. By doing it randomly, you really test your memory. Now, revision's important, and I would recommend something like spaced repetition. So don't just repeat it today, repeat it again the next day, and then the next day, and then 3 days later, and then 5 days later, and then 10 days later, and then 30 days later, and then a year later. What happens then? Well, you'll remember it for life. Fascinating. Test it out. Let me know if it works. Feel free to watch the video several times over if you want as well. I feel like that would work. Maybe on like 1.5 times. Why not? Okay, next one. Very, very important. Expand on the memory layers. Once you have this fundamental structure in your mind ingrained in your memory, why not add to it? You can totally expand. You can learn so much more about the elements. Okay, well done. There's some suggestions there as well. I would recommend group number. That is critically important. If you're a little bit higher in your level, absolutely go for the electron orbitals. How powerful would that be? You can add in the valence structures. That is pretty cool. And maybe the SPDF orbitals. Man, that would be cool. Okay, that was pretty intense. We made it. Was that 20 minutes? Did anyone keep track of time? I think that was 20 minutes. Hopefully 20 minutes or less. That was the goal. But there it is. I will now claim that you have mastered the first 20 elements. But practice makes perfect. We can't say practice and then not do practice. Let's quickly fly through. So, element number 1, sun, balloon, battery, gear, soap. Very easy. I'm sure you can recognize them. Next one, we had diamond, fertilizer, water, a little bit of toothpaste, and that light bulb. Next one, salt shaker, fireworks, airplane, chip, and our matchstick. Must be someone's birthday. Next one, acid. We got that little guy swimming again. We got the welder, the classic bananas, and the milk. Areteerga Academic Institute of Excellence presents the periodic clock. Well done, you made it through. You have mastered the first 20 elements. Now, if you've enjoyed this content, by all means, consider liking and sharing the video. Surely someone else out there needs to learn this as well. Challenge them, or maybe show off your knowledge first and then show them how you did it. Like a magic trick. Next challenge. Now, the periodic clock is cool, But have you heard of the periodic pizza? That's right, there's another. We'll save that for another video. Pretty cool. I won't even give you a teaser now. Like and subscribe. Stay tuned for the next one. Now, if you've got a topic request, feel free to leave it in the comments. I'll see if I can keep up with those comments. If you want a challenge, you should definitely check out some of the word finds, crossword, or jigsaw that I have on my webpage. So that's www.areteerga.com. Check it out. It's pretty cool being able to design your own website. It's really fun. Okay, well done. Here's a quick sneak peek of the website, at least in its current form. I'm bound to update it over time. Definitely check it out. Some other cool topics there, and you may find other things of benefit. Things like how to build your confidence, how to build critical thinking, focus, mood, and the others I'm still working on. Give me some time. I'll add those up as soon as I get a free moment. And on that note, I'll leave you with a quote. Did I intend for that to rhyme? Maybe. This was by Albert Einstein, absolute genius. Here it is. Logic will get you from A to B. Imagination will take you everywhere. And on that note, you're in the clear. I'll see you on the next one.